Learn VR MR. Come to the Spatial XR community.
Hello everyone, and welcome to the Unity Apple Vision Pro development tutorial series. In this tutorial, I will introduce how to configure the environment for metal rendering mode in Vision OS within Unity. First, I will create a new project. Click on Create New Project in Unity Hub. Then choose a Unity editor version. I am using Unity 6000.0.29F1. I recommend that you use Unity 6 for metal rendering mode development. Next, I will choose the Universal 3D template. So my Unity project will use the URP rendering pipeline. Then I will fill out some project settings, such as the project name and the directory where the project will be stored on my computer. Okay, I'll name the project Metal Demo. Since I'm using the international version of Unity Hub and Unity Editor, there will be an option to select a Unity organization. I have already made the selection, and now I can click Create Project to create a new Unity project. Wait for a moment. Okay, now the Unity project has been successfully created. Next, we click on File in the Unity menu, then Build Profiles. Here, we need to switch the build platform to Vision OS. Click on the Vision OS option and then click Switch Platform to change the build target. Okay, once you see Active appear next to Vision OS on the right, it means the project's build platform has been switched to Vision OS. Now, in the Target SDK section, if we are deploying the app to a physical device, select Device SDK. If we're using the simulator, select Simulator SDK. Okay, since I will be deploying this app to the Apple Vision Pro device, I will choose Device SDK. Now, I can close this window and click on Edit in the Unity menu. Open Project Settings, find XR Plugin Management, and click Install to install it. After the installation is complete, the XR Plugin Management interface will look like this. Find the Vision Pro icon, and here you will see Apple Vision OS. We need to check this option. Our Unity needs a Unity Pro license to check Apple Vision OS. So I will check it. It will automatically install some related packages. Once the installation is successful, you will see more options under XR Plugin Management. Click on Apple Vision OS. The app mode here is set to Metal Rendering Mode by default. You will see that Metal Rendering with Compositor Services is selected, so we can go with that. Then, under World Sense and Usage Description, we can fill in some information. This parameter allows the user to grant permission to access spatial data when the app is opened. The text entered here will appear in the system's pop-up dialog. For example, I can enter input. Okay, once the program is first launched, the Vision Pro system will display a pop-up window, asking the user to grant permission to access spatial data. In that pop-up, it will show the word input that we entered. Okay, let's check this option too. If this option is not checked, you may encounter errors during the build process. Then, click on Project Validation and click Fix All. It will automatically fix any environment-related issues. Okay, once you see that all the checkboxes in the list are green, it means the environment configuration for this platform has been successfully set up. Now, we have selected the Vision OS icon. So these settings are related to the Vision OS environment. Okay, now we have successfully set the app to run in metal rendering mode. In my previous Vision Pro development tutorial, we selected RealityKit with Polyspatial, which would have automatically imported the Polyspatial development packages. And the entire app would have used Apple's RealityKit rendering pipeline. However, if you've already decided that your project needs to use the metal rendering mode instead of RealityKit, you don't have to select RealityKit with Polyspatial, meaning you don't need to import the Polyspatial packages. Once we set the app mode to metal rendering with Compositor Services, Unity will automatically import some development packages for us. We can click on the Window menu and open the Package Manager. In the Unity Package Manager, you will see the Apple Vision OS XR plugin. This plugin is required for development in the metal rendering mode, and it's automatically imported by Unity after we set the metal rendering mode. The default version of this plugin is 2.04, but when I recorded this video, the plugin version had already been updated to 2.12. We can click on Version History, then click on See Other Versions, and see that the latest version is 2.1.2. I'll use the latest version for this demonstration, so I will click Update to upgrade to the new version. After the upgrade, you will see that the version of the Apple Vision OS XR plugin is now 2.1.2. Okay, if we are developing for the metal rendering mode, all we need is the Apple Vision OS XR plugin as the underlying plugin support. Then, combining it with Unity's XR development plugins, such as XR Interaction Toolkit, XR Hands, and AR Foundation, will allow us to develop interaction features in the metal rendering mode. You can also see that Unity has automatically imported the AR Foundation package. With the default version being 6.03, but the latest version is 6.04, so let's click Update to upgrade it. Okay, now it's upgraded successfully. I'll go ahead and import the XR Interaction Toolkit and XR Hands packages as well. In the Unity Package Manager, click on Unity Registry. Then search for XR. Here you will find the XR Interaction Toolkit. This is a cross-platform interaction development package officially provided by Unity. It enables common interaction modules, such as grabbing objects and ray-based interaction with UI. This toolkit is cross-platform, so its features can be used not only for Apple Vision Pro development, but also for most XR devices, such as Quest and Pico, can also use the XR Interaction Toolkit to develop interaction features. Additionally, XR Hands is a general-purpose hand gesture tracking toolkit released by Unity. We can use this toolkit to implement functionalities such as hand, skeleton tracking, and gesture recognition. So, click Install to install the XR Interaction Toolkit. Okay, the package is installed successfully. Then we check its version, and the current version is the latest 3.07. Okay, no issues there. Now let's install XR Hands. Okay, now the XR Hands package is also installed successfully, and it's the latest version. Then we click In Project, find Apple Vision OS XR plugin, and click on Samples here. Unity provides us with sample scenes for metal rendering mode. We can import the corresponding scene based on the rendering pipeline used in our Unity project. For example, since my Unity project is using the URP rendering pipeline, I will find the metal sample URP and click Import to import the metal sample package that is adapted for the URP rendering pipeline. Okay, it's now successfully imported, and we can close this window. Okay, after importing the sample scenes, you can see that a new option has appeared in project settings. Hands Tracking Usage Description. Similar to the World Sensing Usage Description, this is a description that will request the user's permission to access hand gesture tracking data the first time the program is opened. The Hands Tracking Usage Description is for requesting the user's permission to allow the device to access hand tracking data. We need to fill in some information here, and I'll just enter a random word. Okay, now there are no errors. Unity has placed the metal rendering mode sample scenes in this directory. And inside there is a scenes folder that provides 2 sample scenes. For example, let's first open Input System UI, which is a relatively simple sample scene. In this scene, we can interact with the UI here, such as clicking buttons or dragging sliders. The top section allows us to play or pause a particle effect by clicking a button. And the speed slider controls the playback speed of the particle effect. The right section of the scene is a debug window that shows the current frame rate of the application. Below that is an important feature, the Show Path-Through button. When we click this button, the scene background is initially a virtual skybox. After clicking, the virtual environment switches to a pass-through reality environment. So, by clicking this button, we can toggle between VR and MR modes. One click switches from VR mode to MR mode, and another click switches back from MR mode to VR mode. We need to ensure that the version of the Apple Vision OS XR plugin is 2.0 or above to switch between VR and MR in the metal rendering mode. Additionally, we need to make sure that the visionOS system version is 2.0 or above. Only with visionOS 2.0 or higher can the metal rendering mode enable the MR functionality. The other sample scene is called Main. This scene is more advanced compared to the input system UI scene, adding many more features. Just like before, we have UI elements to interact with, but here, there are two cubes that we can grab at a distance using gaze and gesture controls. Alternatively, we can grab the cubes up close by pinching the thumb and index finger. This scene also includes some AR/MR features. For example, it has an AR systems component where we can control various AR features like plane detection, mesh detection, image recognition, and object recognition by clicking buttons. These are features provided by AR Foundation. Even in VR, we can use AR Foundation to access real-world spatial data to implement AR/MR functionality. You can see that the XR Origin Player object integrates AR Foundation features such as plane detection, image recognition, and spatial anchors, which can be used in the metal rendering mode. Object recognition is also supported and relevant scripts are integrated. Okay, next we'll package this sample scene and run it on the headset. One thing to note is that the metal rendering mode has fewer limitations than the RealityKit rendering mode regarding some Unity features. But it also has its drawbacks. For example, metal rendering mode cannot stream the app for real-time debugging directly on the headset. We need to package and deploy the app to the headset to see the effects. In contrast, when developing with RealityKit rendering mode, we could use the Play to Device feature in Polyspatial. With Play to Device, once connected between the Unity editor and the headset, you could click the play button in Unity and immediately see the scene on the headset, without needing to package the entire program. This enabled real-time debugging. However, metal rendering mode lacks a streaming tool like Play to Device, meaning we can't see the Unity app's live output on the headset during development. Although we can debug using the keyboard and mouse simulator, this method is only suitable for simple features. If we want to see how the app runs on the headset in real time, we must package and deploy it. This is a bit of a hassle. Hopefully, Unity will introduce a similar real-time streaming and debugging tool in the future. Which would greatly improve development efficiency. Another drawback is that there is very little development documentation available for metal rendering mode. Even Unity's official documentation scarcely covers the development details of metal rendering mode. Unity only provides these two sample scenes for reference and learning. So, when choosing metal rendering mode, You need to be mentally prepared for this. Of course, in this series of tutorials, I will cover some important considerations when developing with metal rendering mode. Not long ago, I used metal rendering mode to develop a showroom project for Vision Pro, which combines both VR and MR features. To ensure that the showroom scene looks visually appealing, the artist used some visual effects, such as shader effects, particle effects, and lighting-baked effects, to make the scene appear more realistic and comfortable. However, many of these artistic rendering features are not supported by RealityKit rendering mode. And manually converting these features to RealityKit would be very time-consuming and technically challenging. Therefore, we ultimately chose metal rendering mode because these artistic effects can seamlessly integrate into metal rendering mode without the need for additional adaptations. Additionally, the project also used some functional modules, such as image recognition, gesture recognition, and UI interactions. These functional modules were introduced in previous tutorials where we used RealityKit rendering mode. Now, in metal rendering mode, we can still use these features without needing to make any changes. So, overall, developing in metal rendering mode has been relatively smooth. The only downside is that if we want to see the program's actual effects on the headset, we need to package and deploy it each time, which can increase development and debugging time. Moreover, if we directly package and deploy this scene to the Apple Vision Pro device, we might encounter some errors, especially in the current version 2.1.2. For example, after packaging, we may not see the virtual environment. Only the real environment, or no virtual objects at all. We might also successfully see the virtual environment, but when switching to MR mode, the background could turn black instead of showing the real environment. These are some of the issues I encountered during development. Next, I'll teach you how to solve these problems. First, we need to make some manual adjustments in Unity. Click Edit in the menu, open Project Settings, find Graphics, and scroll down. Under URP, check the Render Graph option. Then, go to Project Settings and click on Quality, where different quality levels are set for the project. This includes PC and mobile quality levels, and the mobile quality level supports Vision OS. To the right of the mobile quality level, you'll see the Vision OS icon with a green checkmark, indicating that this quality level supports the Vision OS platform. Click on the mobile quality level, then find Render Pipeline Assets below. Click it. This is the URP configuration file for the Vision OS platform. When you click on this configuration file, Unity will automatically locate it in the project. Open the Vision OS URP configuration file, and under Quality, uncheck HDR. After unchecking this option, we will be able to see the real environment properly when switching between VR and MR instead of the black screen. Now, some of you may have questions about this. Let's first click Graphics, where the URP configuration file is referenced. This is using the PC ERP configuration file, which acts as a global rendering pipeline. Meanwhile, under Quality, 2 quality levels are set. And each quality level's render pipeline asset parameter refers to the corresponding URP configuration file. In fact, when we package the program to run on the headset, Unity will select the mobile quality level, which supports Vision OS, and use the corresponding URP configuration file for rendering. But why does Unity choose the mobile quality level's URP configuration file instead of the global PC configuration file? Here's how it works. When different quality levels are selected in the quality settings, and each quality level references its corresponding URP configuration file. The rendering effect in the scene will change according to the selected quality level when we click the Run button in the Unity editor. However, when we package the program to run on an actual device, Unity will automatically choose the corresponding quality level based on the running platform. Since we are packaging the program for Vision Pro, Unity detects that it is running on the Vision OS platform and automatically switches to the mobile quality level, using the mobile URP configuration file under that level. If no URP configuration file is referenced for a specific quality level, Unity will then use the global URP configuration file set in the graphics section. This is an important concept to understand. Now, back in the scene, there are a few points to mention. First, find the XR Origin Player object, expand it, and locate the main camera. Ensure that the post-processing option is not selected. Currently, Metal rendering mode does not support post-processing effects. If this option is checked and you package and deploy the program to the headset, you may encounter a black screen issue where the entire program fails to display. Therefore, we must make sure the post-processing option is unchecked. Another point to note is the clipping plane's parameters in the camera component. The FAR parameter is set to 20, meaning that the camera can only render objects within 20 meters of it. If your scene is larger than this 20-meter range, you will need to increase the FAR value. Now that the necessary settings have been completed, we can try packaging the program and deploying it to the headset. First, click on the File menu. Open Build Profiles, then click on Scene List. And click Add Open Scenes to add the current scene to the list of scenes to be packaged. Then, remove the default sample scene. Make sure that the first scene to be entered after packaging is listed first in the scene list. Now we are packaging the main scene. Next, click on Vision OS and then click Build to start the packaging process. After selecting a folder to store the build, the packaging will begin. Once Unity finishes the build, it will convert the program into an Xcode project. After that, we will open the converted Xcode project on our Mac. In Xcode, select Open Existing Project. Navigate to the folder containing the Xcode project and open the file with the .xcode eproj extension. This is the Xcode project generated from the Unity program. After opening the project, we need to set the code signing and link our Apple developer account. Check the relevant boxes and it will automatically manage the code signing for us. Then, select your Apple developer account under the Teams section. Once the setup is complete, ensure that your Vision Pro device is selected at the top and choose Unity Vision OS. Finally, click the Run button and wait for Xcode to package the program onto your Apple device.